I'm Gupta and I'm 10 years old. I'm the founder of tennisforthekids.com. And if you like this video, don't forget to smash that like button and share this video with as many people as you can. And if you're not subscribed to my channel yet, do it and press the notification bell too so that you don't miss any of my videos. So without any delay, let's get started. And before getting started, I'll tell you today's topic. Today's topic is the ultimate Python. So finally, we are getting to do Python. Thank God. And in Python, we are going to study about operators. So this is going to be really fun, but really exciting. So without any delay, let's get started. Dab. So I'll go to Google Chrome. I'll open W3 Schools, but I will open Word also. So usually I don't open Word, but today I will have to explain things like with writing stuff. Okay, so I have to write a lot of stuff also. So I have opened Word also, and I'll go to Python operators. Okay, Python operators. Operators are used to perform operations on variables and values. Okay, so operators are used to perform operations on variables and values. In the example below, we use the plus operator to add together two values. So over here we are printing 10 plus 5. 10 plus 5 is 15. So it will print, oh sorry, it is showing something else. In that example it showed 10 plus 5. So 10 plus 5, it will show 15 because we are printing it. 10 plus 5 is 15. So 15 has come. Python divides the operators in the following groups. Arithmetic operators. So there are arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. So Python divides the operators in 7 types of groups. Arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. So first we will learn about Python arithmetic operators. So arithmetic operators are used with numeric values to perform common mathematical operations. So in arithmetic operators we have like plus, minus, multiplication, division, modulus, exponentiation, and floor division. So let's try it one by one. So x is 5 and y is 3, x plus y, we are using plus y, 8. So 8 is coming. Similarly in subtraction, we are doing x is equal to 5, y is 3, x minus y will be 2. Okay, because we are subtracting 5 minus, we are doing 5 minus 3 and printing it, and 2 comes. Similarly, we have multiplication. 5 into 3, in this example we are printing 5 into 3 and it is 15. X, we are printing 5 into 3 because like x and y are like the value, x value is 5 and 5 type of 5 has come over here, and y's value is 3 and type of 3 has come over here. Okay, now we have division. So like we have addition, subtraction, multiplication, we have division also. So 12 divided by 3, 4 will come. So this is not like floor division. Floor division is something else. This is normal division. So if I give 11 over here and then do it, there will be a number that is exactly dividing 11 by 3. So 3.6, I don't know how many 6s are there. 5 is exactly dividing 11. So this number is exactly dividing 11. So if we multiply this into 3, then it would be, let's try it. If I like copy it and like do this into 3, then 11 should come. 11.0, yeah, 11 is coming. So this is exact, it divides it exactly. It is not floor division. Okay, then we have modulus. I'll just tell you what is floor division. Modulus, so in this the remainder comes, so like whatever 5 divided by 2, its remainder, and its remainder is 1, so 1 has come, so it brings the remainder of a division. Then we have exponentiation, and in this you must have heard of multiplication, but in exponentiation we have like it over here it is multiplying 2, it is doing 2 into 2 into 2 into 2 into 2, so 2 it is multiplying 5 times, so 2 into 2 4, 4 into 2 8, 8 into 2 16, 16 into 2 32, 32 has come. 32. Then finally we have floor division. So in floor division, what we have, like in before we had this type of division where I did like 11 divided by 3, exact number came. But over here, the exact number does not come. The floor division rounds the result down to the nearest whole number. Okay, so like 7 is it rounds the result down. Okay, it never like rounds it up, it rounds it down. Okay, so like this can never be 8. So like if we divide 17 by 2, then it would be 8, not 9. Okay, because it is rounding it down to the nearest whole number, so a whole number comes. Now we are doing Python assignment operators. Assignment operators are used to assign values to variables. So like equals to operator, so we use it to assign a value to a variable. So like x is equals to 5 and we are printing x, so 5 is coming. So it is just showing it 5. So 5 has come. Then we have plus equals to. So what does this do? It does is like if you have a variable like named x, and then it is a string variable or a number variable. For example, if it is a number variable, and then you do plus equals to 3. So like for example, the before the number was 5, so before when you declare the variable you did x is equals to 5, and now you are doing x plus equals to 3. So what it is doing is it is same as x plus 3. X is equals to x plus 3. So it is adding the x value with 3 and it is setting that value to x. So like over here I have x is equals to 5 and I'm doing x plus equals to 3. So it is adding this number to the previous x value and 8 comes. Now we have minus equals to, it is same as plus equals to, but it subtracts, so 2 comes because it is minus equals to. Similarly multiplication equals to, so it multiplies the, like it is multiplying this with this and then the result is coming, it is printing it. Similarly with division, okay, so it is doing the same thing with division. Then with modulus also it is doing the same thing, it is bringing the remainder, that is 2 right now, because 5 divided by 3, its quotient would be 1 and its remainder is 2, and modulus brings the remainder and we are printing the remainder, that is 2. Then we have floor division. So it rounds down to the nearest whole number. Okay, so here 1 will come because 5 divided by 3 would be, if we do floor division, then 1 would come. The quotient is 1. And finally, we have now exponential equals to. It is the same as multiplication equals to, minus equals to, plus equals to. So like it is doing exponentiation. So it is doing 5 into 5 into 5. 5 into 5 is 25. 25 into 5 is 125. So 125 is coming. And we are then printing it. That's why we can see 125. Okay. Now these 5 assignment operators are bitwise. So like in assignment they are bitwise. So like this is bitwise, this is bitwise. Okay, so first we will understand the bitwise operators, then it would be easier to understand the assignment operators, these all assignment operators. Okay, so let's understand the bitwise operators. Bitwise operators are used to compare binary numbers. So they compare binary numbers. So like there is operator and its name is AND. It sets each bit to 1 if both bits are 1. Okay, so if we try it, so it is what it is doing. First of all, it is bringing 5's binary number. So 5's binary representation in 8 bits is 0000 and 0101. How do we check this that this is equals to 5? I'll just tell you. What do we have to do? We will do 1 into 2 to the power 0. So 2 to the power 0 is 2 to the power 0 is 1, and 1 into 1 is 1 into 1 is 1. Okay, then we have now we will have this bit, so we will do this bit into 2 to the power 1. 2 to the power 1 is 2 and 0 into 2 is 0. Okay, then we have now we have 1. So here we have 1. So we have now 1. So this bit into 2 to the power 2. So 2 to the power 2 is 4 and 4 into 1 is 4. Then we have 0 into, now we have 0 into 2 to the power 3, and so like this bit is 0. So that's why we are doing 0 into 2 to the power 3, and it would be it is 0 only, because we multiply any number with 0, 0 comes. Okay, so like this, whenever we have a bit 0, so like always like give 0, because you will, in the end it will come 0 only if you do 2 to the power. But whenever you have 1, so like just don't do it 0. Let's go logically. Now we have over here we did 0 into 2 to the power 3, right? Now we have 0 into 2 to the power 4. 2 to the power 4 is 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. Okay, 16 into 0 is 0. Okay. Okay, now we have we have done 5 digits, so 3, 5. Now we have this bit, so this bit, okay, that I am highlighting again and again and non-highlighting it. Okay, this bit value into 2 to the power, what we say, 5. 2 to the power 5 is 2 into 2 4, 4 into 2 8, 8 into 2 16, 16 into 2 32. So 32 into 0 is 0. Okay, this is not line. Yeah. Now we have this bit into 2 to the power 6. 2 to the power 6 is 64. So over here 64 into 0 is equals to 0. So 0 will come. Okay, and now we will have this bit into 2 to the power 7. 2 to the power 7 is 64, just calculating, 128. 128, but 128 into 0 is, 128 into 0 is 0. So that's where 0 comes. And finally, we will add all these numbers. So 0 plus 0, 0, 0 plus 0, again 0, 0 plus 0 again 0, 0 plus 0 again 0, 0 plus 4, 4, 0 plus 4 plus 0, 0, 4, and 4 plus 1, 5. So 5. So this shows that this binary number, 8-bit binary number, represents 5. Okay. So in AND equals to, how is it coming 3? So as I told you, in operators, sets each bit to 1 if both bits are 1. So like we know this is 5, and now we will have to take 3. So what is 3? It is 0 0 0 0 0 0 1 1. Okay. Now you can calculate it by the method I told you right now, and you will see that 3 is coming. So this binary number represents 3. Okay, so now what we are doing, and equals to 3. So what is happening, it is doing, if both the bits, like first it will take this bit and it will take this bit, okay, and see them. If both of them are 1, then the new number it will make, it will have 1 in that place. But if one of them is 1 or none of them is 1, then 0 will come. So over here for 0 and 0, so over here 0 comes, then 0 and 0, 0 comes, then 0 and 0, so 0 comes, then 0 and 0, so 0 comes, then 0 and 0, so 0 comes, then 0 and 1, so 0 comes, then 1 and 0, so 0 comes, and then 1 and 1, so 1 comes. So if we like now calculate this, it represents 1. In decimal value it is 1. Okay, calculated by the method I told you, and over here also 1 is coming. Now we'll see what is OR. OR sets each bit to 1 if one of the two bits is 1. Okay, so now let's see the example of OR equals to. So in OR equals to, it is taking the example of 5 and 3. So we have the binary representation of 5 and 3. Now let's calculate the number. 0 and 0 will come 0. 0 and 0 will come 0, 0 and 0 will come 0, 0 and 0 will again come 0, 0 and 0 will come 0, 0 and 1 will come 1 because it is OR. Then 1 and 0 will also come 1 because it is OR. And 1 and 1 will also come 1 because like they both are matching. So this binary number represents, let's just calculate 1 into 1 2 to the power 1 2 2 2 and 2 into the power of 4 7. So this number represents 7 in decimal value, and the result is also coming 7. So our calculation was correct. Now let's see XOR. Sets each bit to 1 if only one of the two bits is 1. So it is like almost the same as OR, exactly OR, as we can say. It is exactly OR, but what happens if both the bits are 1? So like if over here 1 and 1, if these both bits are 1, so 0 will come. If both the bits are same, so like if both the bits are 1, then 0 will come. If both the bits are 0, then also 0 will come. But if one bit is 0 and one bit is 1, then 1 will come. So over here, let's calculate it. So like we have, let's see the example. It is an example of 5 and 3 only. So 5, we have the binary numbers that represent 5 and 3. So let's calculate it. 0 and 0, 0. Then 0 and 0 will be 0. Then 0 and 0 would be 0. Then 0 and 0 would be 0. Then 0 and 0 would be 0. Then 0 and 1 would be 1. Then 1 and 0 would be 1. But 1 and 1 would be 0. And now if we calculate this binary number represents 6. And let's see the output, and it is 6. So our calculation was correct. Now let's move on to NOT. So it just inverts all the bits. So what does NOT do is, I'll just show you. If I'll just open any example, and like I have this. If I do X, if I do not X, so we have to use it like this. Okay, if I do not X, it will come -6. Okay, because the digits of 5 would be inverted. If we invert these, so all these 5 zeros, these are 5, will be 1 2 3 4 5. This 1 would be 0, this 0 would be 1, and this 1 would be 0. So this is -6. Now you must be wondering, according to my method that I told you, like 2 to the power method, this is like a huge number. It is not -6. So like I'll tell you that whenever we use not, according to the 2's complement, it is a minus value. This is signed. This is a signed number. Okay, so it is a minus value. So like according to science 2's complement, it is -6. -6 will come. Okay, so if you want to know more about the representations of binary numbers, like signed 2's complement, signed 1 complement, and signed like signed magnitude, then do check out my like blog. I'll just open that blog. Where is my blog? tennis soda cans. I'll just search on Google. Where is that blog? I'll just open it. Tennis soda can. Blog, yeah, dot. Here it is. So here is the blog. So in this I have given a whole table. Okay, I've given a whole table related to sine magnitude, sine 1 complement, sine 2's complement. Okay, so like you will see that the first bit, if it is 1, if the first bit is 1, then it is a negative number. If it is 0, then it is a positive number, and the rest 3 bits show the number. Okay, this is a 4-bit signed binary number comparison. Okay, so if I'll just open a calculator and just show you how this is -6. So if I said, this is the inverted one, right? This is the inverted binary representation of 5. So if I do like binary to decimal, binary to decimal, okay, and in this I do I open the converter. So I give my binary number, convert it. So like the number, that big number would be 250 if you calculate it using my method, and decimal from sine 2's complement. So I told you over here that sine, according to sine 2's complement, -6 will come. Okay, so it is showing -6. So I told you according to sine 2's complement, -6 will come, and this calculator is also showing the same thing. Okay, so let's move on. I just wanted to show you this knot. Now we have zero fill left shift. So it shifts left by pushing zeros in from the right and let the leftmost bits fall off. So what does this mean? If we go over here, this is right shift, left shift. So if we go in the left shift, what happens? 40 will come. How is it coming? Like we don't need 3 now. The 3's representation. We only need 5's representation. 0, 1. Okay, we need 5's representation. Okay, so now this is shifting left 3 times. So it is shifting left 3 times. So what happens in left shift? This bit removes and 0 adds first. Then second, like this removes and this adds. Sorry. And finally another left bit will remove, and in the end this will add. Okay, and now if we calculate this, that website was good. No, let's calculate it orally. So if I calculate this, 1 into 2 to the power 3, 2 to the power 3, 4 into 2, 8, 8, 2, 8, 2, 3, 4, 2 into 2, 4 into 2, 8 into 2, 16, 32. Yeah, so this will come 40. So this is not 5, this is 40. This is 40. If you calculate it using my method, 40 will definitely come. And over here, the result is also 40. I think so. Yeah. Now we have to learn signed right shift. So in sine drive shift, it shifts right by pushing copies of the leftmost bit in from the left and let the rightmost bits fall off. So what does this do is, if I do the right example, so this does is like, let's take the 5 representation again. 0 0 0 1 0 1. Okay, so this represents 5. Now we have to shift it right 3 times. So this bit will remove and 0 will add. Now this bit will remove and over here 0 adds. And now third time this bit removes and 0 adds. Okay, and now if we calculate this, this is equals to, this represents 0 in decimal, and if we run this, suppose the answer would be 0 only. Yeah, so we are done with binary operators and bitwise operators and assignment operators. Now let's move on. Python comparison operators. So now we don't need word, we don't need this. So do check out my binary JavaScript video also. You will get to know a lot more about bitwise operators and lot more about bitwise stuff. Okay, so it would really help you, though it is not Python. If you are working on Python, it would be not of Python, it would be of JavaScript, but it would really help you because I am explaining all like the three like I'm explaining sign magnitude, I'm explaining sign 1 complement, I'm explaining sign 2's complement in that. So I'm explaining all 3 of them, so do check it out. So Python comparison operators. So comparison operators are used to compare two values. This operator is equal. So if it checks that it is equals or not. Sorry. Yeah. So like x is equal to 5, y is equal to 3. Print x is equal to y. So 5 is not equals to 3. That's why it is printing false. Now we have not equals. So what does not equal to? It is doing this. So like x is equal to y. Sorry. X is equal to 5, y is equal to 3, and it is printing x not equals to y. It will give us a boolean, and it is giving us true because 5 is really not equals to 3. Now we have greater than. So in greater than, it checks that a value is greater than another value. So like x is equal to 5, y is 3 again, and it is checking x is greater than y, and that is true because 5 is greater than 3. So it shows us true. It returns true because 5 is greater than 3. Okay, now we have less than. So in less than, it is giving us false because x is equal to 5, y is equal to 3, and x less than y. So 5 is not less than 3. That's why it is giving us false. Greater than or equals to. So what is greater than or equals to do? Like it is doing that x is equal to y, y is equal to 3. So x is greater than. So it checks that if x is greater than or equals to. Okay, so it returns true because 5 is greater than or equals to 3. Okay, it checks that if x is equals to y, then also it will return true. If x is greater than y, then also it will return true in greater than equals to. Now we have less than equals to. In less than equals to, if y is if x is less than y, then if x is less than y, then it will return true. And if x is equals to y, then it will return true. But it is returning false because x is greater than y. So returns false because 5 is neither less than or equals to 3. So we are done with comparison operators. Now let's go to logical operators. After that we will do identity operators and then membership operators, and then our chapter will be over because we have done bitwise operators already. So logical operators. Logical operators are used to combine conditional statements. And, so first operator is and. Returns true if both statements are true. So like over here x is greater than 3, so that is true, and x is less than 10, so that is also true. So it is returning true. Returns true because 5 is greater than 3 and 5 is less than 10. Or, now we are on or. Returns true if one of the statement is true. So if we try it, x, we are doing x5, print x is greater than 3, so that is true, or x is less than 4, that is not true, but as x is greater than 3 and it is or not and, so it will give us true. Returns true because one of the conditions are true. 5 is greater than 3, but 5 is not less than 4, so one of the condition is true, so it will give us true. Not. Reverse the result. Returns false if the result is true. So what happens in not? It reverses the result. If the result is returning true, then it reverses the result and makes it false. So like here x is greater than 3 and x is less than 10. Okay, and now it is reversing the result using not, so false is coming. Returns false because not is used to reverse the result. So we are done with Python logical operators. Now we are on Python identity operators. Identity operators are used to compare the objects not if they are equal, but if they are actually the same object with the same memory location. Not if they are equal, so this is very important line. Not if they are equal, but if they are actually the same object with the same memory location. So operator is and description returns true if both variables are the same object. So you see, these both values are same, okay, but z is x. So we are doing print x is z. It will give us true because these both z and x are pointing to the same memory location. If I change z, then x will also be changed. If I change x, then z will also be changed. I'll show you how. I'll do like z 0 is equals to okay. Now you see, if I print over here x, if I print x over here, it is taking time, then this is coming because I changed z, then also x is changed like this because they both are pointing to the same memory location, and when they are pointing to the same memory location, if I change z, then x will also change as they are pointing to the same memory location. Okay, so x is z will give us true because they are pointing to the same memory location as it said, but if they are actually the same object with the same memory location, so true. X is y, this is false because these both are the same objects but they are not pointing to the same memory location. So like they are equal but they are not pointing to the same memory location. That's why false is coming. And now we are doing print x is equals to y. So it is true because these both objects values are same. The memory location is not same, but their value is same. That's why in the end it is returning true. So let's read these comments. Returns true because z is the same object as x. Yeah. Returns false because x is not the same object as y, even if they have the same content. To demonstrate, so now in the final one, to demonstrate the difference between is and equals to, this comparison returns true because x is equals to y. So as I said, that x is equals to y. Now we are on is not. Returns true if both variables are not the same object. So like x is not z, it will return false because really x is not, it is false. X is z, okay, because they are pointing to the same memory location, so it is giving false. So now we are doing x is not y, it is returning true because x and y are not pointing to the same memory location. And now we are doing x not equals to y, so it is returning false because their values are the same. Okay, now finally we are on membership operators. Membership operators are used to test if a sequence is presented in an object. So let's read it once again. Membership operators are used to test if a sequence is presented in an object. So operator in returns true if a sequence with the specified value is present in the object. So I'll just explain. Like we will like we are checking that banana in x. So we are checking it and banana is in x. So it is giving us true. Now if this was a string, this whole array was not an array. It was in string. It was not a list, it was a string. And then I run it. So this will show that this works on strings also. Now if this is not a string also, it is a tuple. So I make it a tuple and then try it. So it will again give us true. Now it does not work on numbers. If it is if it is an, I'll say, like dictionary. Dictionaries don't work like this really. It will not work. False. It does not work on dictionaries really. Okay, so this works on tuples. Okay, it works on tuples, strings, and lists. I can't think of anything else to test it on. I know that it does not work on numbers, and I can't think of anything else to test it on. So just comment down below and suggest some like types on which I can test it that it works or not. Okay, and if you have any query related to this chapter, comment down below. If you have any query related to the bitwise, comment down below. And if you have like query related to a bitwise um signed magnitude or signed ones complement or signed two complement, do comment down below. I will surely help you in all of your, I'll try to answer all of your questions. Okay, so let's continue with the chapter only. Not in returns true if a sequence with the specified value is not present in the object. So like if we are doing pineapple not in x, so pineapple is really not in this list, so it is giving true. If I gave banana not in x, so it will return false because it finds banana in it, right? So this is done, and we did bitwise, and it's over. So today we learned all about operators. Thank you guys. If you like the video, don't forget to smash the like button and share this video with as many people as you can. And if you're not subscribed to my channel yet, do it. And press the notification bell too so that you don't miss any of my videos. Thank you guys. Bye. Stay safe, stay healthy, and keep watching my videos. And please subscribe too. Bye guys. Dab.